Hey guys, Abraxas here, and I'm going to be playing some Space Engine. So let's go ahead and get started. And this is a face that appears to keep showing up in my videos recently as IC1101's supermassive black hole. So here it is. And I'm actually going to start this video off with, let's see. Oh yes, one from Plazasta? Plazasta? I think that's how you pronounce his name. And we have yet another Big Bertha. Apparently his is 1.66.87, or did I say 1.66? 166.87 astronomical units. So it's actually slightly bigger than the previous star. So, I mean, here's another kind of record for the star, I guess. So, sorry, EN07, I guess your record's been broken already. So, let's just go ahead and check this out. And there it goes. Now it's pasting. And it is a red supergiant. M9.9 IB. That's what he mentioned was it's IB, not IAB. I don't know what the classifications are. I'm going to have to look into that. But, yeah, as you can see, it's actually the new Big Bertha again. Of course, I will say this doesn't have that awesome galactic cluster in the background, it appears. But it does have like a nice little kind of purplish hued galaxy. Let's go ahead and zoom out here. It looks like it's kind of like a ring galaxy, I think. Oh no, that's actually a spiral galaxy. What I found interesting is this is not like in an elliptical galaxy or anything like that. It's actually just sitting in a normal spiral galaxy. Interesting, because normally these are pretty old stars. But yeah, here is the next new biggest star, and it actually has some planets kind of orbiting around it. Now, I'm just gonna, for the sake of... Oh, it's a dual planetary system. There's a dual planetary system orbiting around it. Very cool. But this is sitting at a distance of 9 astronomical units. This is sitting from this star 98 astronomical units. That's the distance between Earth and our sun. And is in our view. Yeah, that's kind of an idea of how big these stars really are. Incredibly huge. Impossible stars, but in the game it's just madness, pretty much. And if we check out the orbits, you can see that it is a very, very compact little dual planetary system. Like, these are not far from each other at all. In fact, this moon here is sitting at a distance of 5,000 kilometers. Not far at all. It's like the radius of Earth, pretty much. One Earth would just sit in the center of this, pretty much. So, very cool. That's actually the most compact, like, little dual planetary system I've actually seen in the game, I believe. Very nice. So let's go ahead and move on to the next edition, which is from Derp Sauce Gaming. And he mentions, well, by the coldest place, I mean the coldest natural place. Yeah, I knew what you meant, but I figured I'd just mention that, yeah, we've gotten close. I think we might have actually achieved absolute zero in labs and stuff. Naturally occurring, absolute zero doesn't really naturally occur very much in the universe at all. It's actually a very rare phenomenon. Oh, wait. Okay. Actually, let's go back to Plazista. I just noticed he actually has a response to his comment right here. And let me check this out real quick. And here we go. Red Luminous Supergiant, M9.9 IA. So it's another huge giant star. This one is 159 astronomical units, so pretty big. But it seems like, yep, there's a little tiny black hole here. It has a mass of 300, which is the max amount of mass that things could actually have in this game. So that's why they have matching mass. He was pointing that out, so that explains why they have the same mass. That's actually the limit. It's just the diameter could actually be bigger, but yeah. Oh god, it's a song again. Let's just not even. Okay, so now let's move on to Derp Sauce Gaming suggestions. So he has a Terra in the Sunflower Galaxy. I've never heard of that galaxy before. Good suggestion. It's also a Terra in the same galaxy. So let's go ahead and check this out. And here we go. So this is the Sunflower Galaxy. It looks like it's a relatively compact galaxy. Also, it's a beautiful Terra, but let's go ahead and zoom out here and check out this galaxy real quick. Why would this be called the Sunflower Galaxy? It's kind of bluish in the actual image here. I don't know if that's an actual... Oh. Okay, the game crashed, so... One moment. And... Come on, there it is. Okay, there it is. And back at IC 1101 again. You just keep showing up, don't you? Okay, let's go back to that Terra. So yeah, it was actually a kind of purple spiral galaxy. It wasn't actually what I expected. But I don't know if it just reused images from its kind of little catalog of galaxy images it uses, or if it, this is like a custom image for the galaxy and what it's actually looking like. But if we come over here, we have a nice kind of, not really so much a rainbow ring, but it's kind of a pink to orange, green, blue, and then violet, and then orange again. So nice little ring system, and here's our Terra with Life, which as you can see is absolutely pimpled with craters from some type of large collisions, kind of big nasty collisions. And you can see it has some nice polar ice caps, which this polar ice cap actually has a collision as well. There's actually a little bit of water down here. Check that out. I think that might just be like an asteroid or meteor, I guess, collided into this planet, exposed a lake, and then it froze over. Like it kind of just filled up with water and then froze over, because that's what that kind of looks like right here. Can you see that? Can you actually fly under this? I highly doubt it. No, you can't. So yeah, we kind of got like a little frozen lake here. Very nice. It's actually the first time I've actually seen anything like that in this game. Very cool. Oh, and check out that view. That is a really nice view. Very cool. And let's check out the life, which should be right over here. Okay, so it looks like we're kind of in like a rocky surface. Got a brown volcano here. It does say marine and terrestrial life. That looks like life. Yeah, there we go. So it looks like, I think that's a grass texture blended in with something else. Let's go somewhere where we can actually see it a little bit better. Somewhere a little bit brighter, such as over here. Let's go ahead and slow down. We have some lovely eroded hills. Nice rolling hills, look very nice. And at the top of the mountains, it's actually a little bit darker. Okay, so that's like kind of the forest texture, I think. I don't know what this one is. Does anyone know what this is? It looks like some kind of grass, but I don't really know. It could be like palm trees or something. It's kind of this weird star-shaped grass. I see it occasionally. And over here it looks like just kind of root forest. As you can see, that looks like a satellite image of a forest. Yeah, I don't know what that star-shaped one is. If anyone knows what type of like plant life that is, let me know. So we have the sedimentary rocks, but it's nice and blended with like kind of a brown color, making it look a lot more, I don't know, less deserty and kind of more blended in with this terrain a lot better. So really nicely generated. You can see the huge rings in the background there. And kind of low-lying cloud layer, I think. Let's go over to where the cloud layer is. No, it's actually pretty decently high altitude. Okay. CO2, oxygen, nitrogen, diameter of basically that of Earth. The ESI is actually 97%, so this is extremely Earth-like. Its semi-major axis is 0.55 astronomical units, which means this is probably an orange dwarf. So, very cool world. Actually, I really like the fact that it's actually 97% ESI. It does look like it did not fare very well against some asteroids, so... Speaking of asteroids, here's a little asteroid right here. And there it is, just slowly moving across the sky. Because I do actually have the time moving. Let's go ahead and pause that for the sake of performance. And I imagine since the atmosphere composition is pretty similar, and yep, a very Earth-like sunset. Given these mountains will stop rendering. There we go. So, very cool. And over here you can see what looks like a evaporating planet. Yep, it is a scorched desert. Very cool. Let's go ahead and move on to the next suggestion, which he says is another Terra in the Sunflower Galaxy. No further details. Let's just go ahead and check it out. And here we go. Cool tower with life. Sitting at a semi-major axis of 0.79, which tells me it's probably a red dwarf that it's orbiting around. There's a nice little Selena moon. No, it's actually an orange dwarf, I do believe. Yellow dwarf. Okay, so it must be like transitioning between orange and yellow, or just kind of a start of a yellow dwarf. Anyways, we have a nice cyclone right here, with a volcano spewing out some type of weird sludge. Kind of clipping through it. With a green color. That's not life, is it? I highly doubt that. It actually is. That's weird. Why would life grow right there? And as we go into the atmosphere, it's a really, really foggy blue atmosphere. Oh, and check that out. It's kind of got like a grass texture kind of growing into these, I don't know, cracked mud texture. That actually looks really cool. It's actually really nicely blended. I like that. And something over here. Yeah, whatever that orange stuff is. It's kind of like over in that area. Yeah, that's actually really nice. I actually really like the way that's blended together. Kind of looks like the edge of like a desert salt lake. Over here we have like kind of this, what would you call this? Marshy terrain, I guess? I'm not sure. This would be like swamp terrain, wouldn't it? Of course, we don't have like three-dimensional trees or anything like that, but it looks like kind of swamp terrain or something. And there's our grass texture. The ESI is not quite as high on this planet. It's actually 82%. We have these lovely clouds here, which I think this is the edge of that cyclone. Oh, it certainly is. Very nice. You can see a little asteroid just shining there. And let's check out these rings. Actually, just kind of a very nice little world. That looks incredibly weird with the cloud clipping through that like that. And you can see the sedimentary rock texture is not as nicely generated on this hillside. It's got like the nice erosion effect, but this hill area is just kind of buggy and weird. Anyways, cool planet. Not a very high atmospheric pressure, but once again, CO2, oxygen, nitrogen. And it has a diameter of 18,000 kilometers, so it's actually quite a bit bigger than that previous planet. Okay, so our next suggestion is from Infrared. And he says it is a terra with a cool purple tinge. So let's go ahead and check that out. Wait, there we go. Temperate terra with life. Nice purple color to it. It has some polar caps, a little Selena moon there. Asteroid moon. I think that is a brown dwarf? Red dwarf. Okay, so this is a multi-star system, and the primary star should be up here, which is an orange dwarf? Yellow dwarf, okay. And really, really detailed world. Check this out. We got some beautiful snowy mountains, and wow, this one's actually just really, really cool looking. That looks like a huge crater. And over here we have our polar cap with some mountains kind of generating through it. Very nice. Let's go ahead and just land right over here in this kind of sunset region. Okay, so we have kind of a pinkish sunset going on. Nice reflection across the water here. You see everything's just purple. There's the polar cap there, kind of like huge snow mountains. There it is, just rendering and generating. Very, very cool. Looks like we might have multiple cloud layers. Yeah, we do. Okay. Over here should be our life, which I think is, yes, marine and terrestrial. So let's go ahead and check this out. Let's go over here right where these snowy mountains are. So we got some nice rolling eroded hills. Very natural looking, quite Earth-like. I want to point out that ESI is actually 89% on this world. So we have our standard grass texture. And I'm not too sure what this one is, but... Okay, it looks like kind of one of the treetop textures, like satellite image treetop textures. But everything kind of seems like it's a lower resolution on this planet for some reason. I'm not sure why that is. For the stone, it looks like just sand, kind of. Has a sand detail mapping. Ah, yeah, there's winded sand across these hills. And then over here we have the standard sedimentary cliffside rock texture. As it renders in, has that kind of rough, coarse granite look to it. And we have our lovely snow peaks. Oh, check that out. Wish I had pictures on this planet. Nice. Very cool looking world. If you guys want to visit the planet, the ID, as always, is in the top left corner. For those who are kind of playing along at home. So the question, once again, is from Infrared. Let's go and check it out. He says it is dark terror with black land. That sounds interesting. That just makes me kind of wonder, what does this look like with real planet brightness on? Is it going to be dim? No, it's actually a little bit brighter. Okay, so let's go ahead and check this out. Get rid of that question mark. Here we go. Green atmosphere. I assume it's probably going to be like a pinkish sunset or something. A little bit. That's actually kind of orangish. Very weird. Got our lovely aurora effect over here. Some nice polar caps. Actually, some really, really large polar caps. It's almost kind of a snowball planet. And let's just go ahead and dive right in. So this apparently has black terrain. Okay, so that's a pretty big mountain range over there. But at least it does fade off with some nice hills right here. Actually, that's not very tall, is it? No, not really. It's not really a high altitude mountain range, it's just big in volume, I guess, or kind of width, whatever. Surface area? Surface area, that's what I'm looking for. We got nice rivers kind of cutting through these mountains here. Got our sedimentary rock texture, which actually does make sense here. So I'll give it that. And what's going to generate here? Looks like winded sand. Kind of the same deal over here as well. I'm having a hard time trying to find some life, which this might be. No, I can't really find any life. It's kind of hard to find it because the green atmosphere is kind of throwing me off here. This? No, there's just more sand. Oh wait, I see something. We got something here. Flying too fast. Flying way too fast. Okay. What is this? I can't tell. That is something. Well, you said it had black land. Maybe if I turn on real planet brightness... It's a little bit darker, but not really black. It's kind of brownish. It's a really nicely detailed world, though. I mean, look at this. That's a very nice view. And we are above a galaxy. Check that out. That is a nice view of the galaxy from here. Let's go to the dark side. See a volcano right here. Doesn't appear to be active, though. Yeah, really, really lovely view of the galaxy in the night sky. But, very cool. Let's go ahead and move on to the next suggestion, which is from Neff Diggity Dog, and he says, Kepler 37b, exoplanet with the smallest radius. Okay, let's try that again. Kepler 37b. There it is. Okay, so I assume I want to go to this planet. And here we go. Warm ice giant. So there's the parenting star, and it has a radius of... well, diameter of 55,000 kilometers. So big diameter, radius. What do you mean by radius? Like semi-major axis? No, that wouldn't be correct. Radius. Radius is center between, or from point to center to edge. I don't know what you mean by radius. Gas giant with the smallest radius, possibly? Exoplanet with the smallest radius. So this is the smallest exoplanet that we've actually seen. No, that doesn't sound correct. No, I'm a bit confused. Somebody's gonna have to correct me down in the comments. I'm totally overlooking something here. Yeah, I'm definitely overlooking something. Radius. I do think we've seen smaller exoplanets. I mean, there's terrestrial ones we've spotted. This has a diameter of 55,000 kilometers, so I mean, it's quite big. And are we in our neighborhood? I don't think so. I see the Carina Nebula. I see Barnard's Loop, though. What's this? North American Nebula. Okay. So Barnard's Loop should be over here, right? I see. Of course, Barnard's Loop doesn't really have a high magnitude in this game. Well, I'm not too sure. There's Barnard's Loop. Yeah, it doesn't have a really high magnitude. Okay, so that's why we're sitting way up there. But, yeah, if somebody wants to correct me on that, I'm a little bit confused. Or a lot of bit confused. Not sure. But, let's go ahead and move on to the next suggestion, once again from Neff Diggity Dog, and he says, this is the densest exoplanet. How do we measure density of an exoplanet? So B. And here we go. K2, 22B. This is 24B. This isn't correct. There it is, right there. And it is a scorched desert. Okay, something funny is going on there with the storm. I assume if I get closer it might fix itself. No, apparently not. What if I get further? There it goes. Oh, and it bugs again. That's weird. I can't really explain that. Just touch down on this thing and look at this huge star here. This is just a yellow... No, it's actually just a red dwarf, but we're just so close to it that... yeah. It's kind of interesting seeing that without the cloud in the way, though. We just kind of have, like, the red atmosphere of this planet. Oh, there it goes. Well, that looks a little bit more natural. But still, that is... yeah. Probably wouldn't be too comfortable standing there. And this is the densest planet, so it has a mass of 0.6, a diameter of... I'm looking at the star. Okay, it has a diameter of 31,000 kilometers? Terrestrial world. Terrestrial world, not a gas giant? Has a mass of 34, so very, very heavy world. But yeah, that is a very, very big terrestrial world. I'm not used to actually seeing that in this game. That's pretty crazy. And you can see its huge comet tail. Well, it doesn't really have much of a comet tail, but it has kind of a glow of its evaporation. Maybe that was a gas giant, but it was demoted down into a terrestrial world as the gas was burned away. That's a possibility. Okay, so just out of... I don't know. Yeah, just kind of sheer luck. Kara Hoff asked, what is the biggest planet you've come across? And I don't mean like a brown dwarf. I mean like a rocky terra. How big can a rocky Terra get? Well, out of planets I remember, this is basically the biggest one I've seen right here. So, here you go. I'm sure I've actually come across and clicked on bigger and stuff. It's just, I don't look too deeply into these things. And when I do, I don't really memorize it because I've done already, like, this is my 70... Is this... I think this might be my 60th video. Yeah, it's my 60th video. So I've gone through hundreds and hundreds of planets on my own time and just suggestions and stuff. So it's like, yeah. It's hard to remember specific planets and stuff. There's only like... I only memorize like huge memorable objects like IC-1101 and all that. It's very hard to keep track of everything. But that's why I just kind of catalog it in videos too. I mean, people can come to like watch these videos and stuff and see some really awesome suggestions that you guys submit. So if people want to find like awesome planets in the game, they can come to one of my videos and get like a nice list of IDs of really cool suggestions from you guys. So it's actually pretty cool. So my next suggestion is from This Is Not Interesting. And he says, go to Betelgeuse 8.4, so go to the fourth planet from Betelgeuse. I've actually accidentally clicked on Betelgeuse before. We're just randomly exploring the Milky Way. I was like, oh, well, there's Betelgeuse. Big star. That doesn't normally happen to me very often. I don't, like, normally I'm just, whenever I click on things, it's like a random star. Unless I'm just kind of in our own little neighborhood here. Like, if I backed out... Like, let's see if I can get into our own little neighborhood. So... There's the Carina Nebula. There is a very bright object. That is a cluster. Okay. Now you have to keep in mind the magnitude of things. Here's a very bright object. Cluster. Okay. Well, I'm clicking on clusters now. What's this? Deneb. I've heard of this star. Let's go ahead and check it out. It is a white luminous supergiant, and it's incredibly bright. A little bit oval-shaped. So yeah, you can just click on things. Betelgeuse has a pretty high magnitude. I just don't know exactly which one it would be. That's a random star. But if you just hang out kind of in the nebula, you'll actually, or not the nebula, but if you hang out in just kind of the neighborhood that we kind of sit in, and just click on like objects that have very bright magnitudes and stuff, you'll eventually find some pretty notable stars that are kind of in our galactic neighborhood. Is that the Flame Nebula? No, it's a North American nebula. So I'm over here, which means here we are. Now we're a little bit closer to home. We sit... Wow. Why is Barnard's Loop not all that vibrant? We sit kind of in this area, I do believe. So this is a little bit closer to home. So if we click on some of these brighter objects, we'll start seeing stars that we actually recognize. A lot of these names. Oh, there's Betelgeuse. There we go. Got it. Yeah, I knew it was somewhere around the Orion Nebula. So here it is. And I didn't even have to type it into the ID. So we got Betelgeuse right here. You want me to go to the fourth planet? And here we go. Hey, Scorched Selena. He says you might want to check the orbits. So, okay, let's go ahead and check the orbits. Oh, okay, that's orbiting rather close. Let's see. Okay, so let's go ahead and hit play and fast forward. That menu's not popping up for me. You see my cursor down there at the bottom left. It's not popping up. So I'm going to restart the game one sec. This game is kind of buggy. Okay, so let's see if this works now. Okay, so now if we hit play, I think what you were... There we go. No. Wait. No, red just means that's what I selected. What's interesting about these orbits? I was expecting like a... Am I missing something here? Well, for one, the objects closer to the planet are moving slower than the one that's further from the planet, so that's a little bit odd. Oh, no, never mind. It was just the way it looked when they were moving very fast. So they're moving with the planet. That's kind of expected. Is there a moon I'm missing here? Let's go to the gear icon. Dwarf moons. No? There we go. Dwarf moons. Asteroids. Okay, not asteroids. They're just kind of orbiting with the planet. I was kind of expecting like a retrograde orbit or something like that, but I guess that's not really what's happening here. They're orbiting kind of facing towards the star. What am I missing here with the orbits? I'm a little bit confused. You tell me, yeah, I can't really work this out. Is it because they're kind of orbiting like upwards like this rather than like horizontal, like a horizontal plane? Well, it's because the planet's rotating that way, so naturally they're gonna kind of. Yeah, I'm a little bit confused. I mean, that probably means that this planet was probably impacted at some point and just knocked this way. But yeah. You know, Betelgeuse is actually a really beautiful star in this game. I think that they actually, or he actually made that generate really nicely. I know it's a big red giant pretty much, but, yeah, it's like really, really nicely generated. It looks really detailed. I mean, the other red giant, or like the super giants and stuff, like the giant meatball star that we visited earlier, is like not nearly as detailed as Betelgeuse is. Cool, let's go ahead and move on to the next suggestion, which once again is from This Is Not Interesting. So, let's go ahead and check that out. And it is a scorched Oceania. Some reddish clouds on the back, and actually some white ones. That's weird. We have a lot of moons. A lot of moons. A lot of moons. Let's go ahead and turn those off. So yeah, this thing has a lot of moons orbiting around it, and it is scorched, so I can only assume once I turn it around. Oh no, it's actually a white luminous white main sequence star. So a very hot star, 6,900 degrees. Watching this poor little Oceania that's orbiting actually 1.35 astronomical units away. So that's kind of gives you a rough idea of how bright these white stars are. And let's just go ahead and check it out. G of 13, mass of 1.9 sun. There we go, that's what I was looking for. And a pretty large diameter. 3.5 million kilometers. Yes, 3.5 million kilometers, so 2.5 times the size of the sun. Pretty big star. And let's see what planets are orbiting around here. So we have this Oceania that we were just at. Let's go ahead and pause the game so we don't have any performance troubles and crashing issues, hopefully. And let's just check out one of these frozen titans that are out here. Check that out. Pretty big. Actually got a diameter of 31,000 kilometers. So actually, no. This is, I think, bigger than that last planet we were at that I was saying was the biggest. So I don't know. I don't know what would be the biggest rocky planet. I don't feel like making another challenge to find the biggest rocky planet, but it appears they get quite big. In fact, for reference here, here's a gas giant that is 39,000, while this Titan here is 31,000 diameter. So that's kind of a general idea of like a small gas giant and a large rocky world. But these Titans, they're beautiful once you turn on the real planet brightness. And there we go. Ooh, actually a really nice blue glow. Are we still in the Milky Way galaxy? I think so. Yes, we are. We're kind of towards the center of it, though. Let's check out one more suggestion from This Is Not Interesting, which I'll go ahead and mention once more that I only accept 2 suggestions per people now because these videos are getting quite long. And as I get more and more viewers, I mean, it's just really, really hard to keep track of all these and try to make kind of a, you know, a short-ish video. I mean, these videos already go up to like almost 2 hours now. And this is a beautiful temperate terror with like a really nice brown color to it. And look at that, it's eclipsing its moon right now. Chose a more perfect like eclipse timing for this planet. It's like dead center of its shadow. Very awesome. Let's go ahead and touch down right here. So is this the water? Or is this the water? This is land. That's the water. Really, really dark world. Oh no, that's not water. Wait, yes it is. Maybe? No, it's sand. What is going on here? Is it doing that fading thing that the water does sometimes at the edges? I think it is. It's a salt lake, but that looks like a river. That might be water. No. Let's turn on real planet brightness to see if that makes a difference. Or turn off, I mean. No, that didn't make a difference at all. What is going on here? Do I have water turned off? I did have water turned off. Okay, that kind of explains a lot. That was just me being dumb, and it's got like kind of a nice blue color to it. Which it still looks like it wants to do the fade off thing. No, it doesn't. Never mind. Okay, so we have an active volcano. That is kind of different looking. The texture on that is weird. Like, what is this gray on the outside? Oh, wow. That actually looks really nice in the atmosphere. The rings actually have, like, a nice, cool, like, gold color to them. Same with the atmosphere itself. And I think the stars there is actually a binary system. Actually, really, really close orbiting binary system. Let's check that out. Check that out. It is a white star. No, it's an orange dwarf and an orange dwarf. Okay. That one looks much more white, though. Very cool. Let's go ahead and head back to our planet real quick. And check this out. Okay, so we have our lovely shadow of our rings, and now that we can actually see the water here, it looks much better. And let's just touch down right here. Those 2 stars look really awesome through the rings. It's a very pretty view. Those rings are casting on the atmosphere here. And off in the distance over here, there is an active volcano sitting there in the dark, shadowy night sky. Very awesome. See why it'd be very, very neat if Earth actually had rings. Even though getting things into orbit would be a little bit more difficult, I think this would look absolutely amazing. And you can see the cloud layer there. Just kind of under the atmospheric layer. Because this is just the atmosphere. This isn't actually clouds. And you got the clouds there. Which are also slightly affected by the shadows as well. You can see it more with this cloud right here. Which is actually the edge of a hurricane, I do believe. Yeah, it certainly is. Very nice world. And it doesn't have any life, but the atmosphere is nitrogen, carbon dioxide, and sodium dioxide. Sodium hydroxide? What is SO2 again? Sulfur dioxide. Why did I say sodium? I meant sulfur. Man. I just watched a Cody's Lab video that was featuring sodium, so, yeah. Actually, one of the more recent uploads. Yeah, if you guys want to check that out, I do have a link to it on my channel page. It's under the recommended channels. I do recommend checking out Cody's Lab. His videos are awesome. So, let's continue on to our next suggestion, which is from Kerry Selznick. And he wants me to go to a 7-star system, NGC 4889, and try to find the largest rocky planet. Oh, he wants me to. Okay, I'm gonna mention this again. I don't like doing the little kind of Easter egg hunts, like find something, find this, find that. It's like I don't really have time for that in these videos. When I do, it's normally just awkward and I have to jump cut a lot. And I rarely ever find what you guys want me to actually find. So this is NGC 4889, which is an elliptical galaxy. Apparently I need to find a 7-star system here. I could use the search tool for that, but I don't know. And it says find the largest rocky planet. Yeah, I just can't really do that. It's a little bit difficult. But let's go ahead and give it an attempt. Let's see if we can find at least the 7-star, which I should be able to do by changing the sun count to 7, hitting OK, and running a search of the diameter is 258 kilolight years. So let's just go ahead and just throw in 1,000 light years and see if we can find something like that real quick. And search. Hopefully this finds something. And here goes a search. And I did not find it. Let's slow down here. And let's just go to the center of the galaxy, I guess. And run the search again. Okay, the game is lagging a bit, but there it goes. Now it's actually searching. And yeah, I'm not finding it. So that was the search tool. I did not find it, but there's a lot of galaxies in this area. It's kind of that we like saw yesterday, pretty much. I'm gonna have to stop the recording 1 sec. The game basically crashed again, but there we go. Recording and all good. So XD wants me to go to a carbon star, so let's go ahead and check this out. You didn't even know this existed? I've actually featured a lot of them in my previous videos. In fact, actually, a couple of my very recent ones. But yeah, carbon stars. They are really cool stars, and they always look very nice. Star. And let's see if there's anything orbiting around it. No, there isn't. But, yeah, carbon stars. If you actually go over into the star browser and go to filter settings, carbon stars should be, yeah, it's an option right there. And sometimes when you, whoops, sorry for bumping the microphone. Sometimes if you search carbon stars and hit OK, you can actually find, if I can find it real quick, not just carbon stars, but here we go. You can find zirconium stars. And they don't look much different from carbon stars or really any other stars. But right here is a zirconium star. So yeah, they're actually just really, really cool. And they're zirconium stars because, well, they have zirconium in them. And yeah, it's very nice. And right here we just have a white main sequence star. Very, very bright in comparison, it looks like. So yeah, I think that is the last suggestion for this video. If you guys like the video, please leave it a like. And if you want to see more videos like this, please do subscribe. It really does help. And I will see you guys in the next one. It's just a play and watch these two kind of orbit around each other.